The first one, and listen, shh, guys, listen. This could be two, shh. This could be two separate questions. One in which it asks you to find the equation, and you'd have to have done it to here. Well, then you would have had to say, if it's arithmetic, I would have said a to the n equals negative 3n plus 23. So if it said find the equation of the, or to find any term in the arithmetic sequence, this is what it's looking for. Order can be switched, like it can be 23 minus 3n, or it could be this, it doesn't matter. But this is what it's looking for. Then it said use it to find the 11th term. Well, it might just say find the 11th term, don't give me the equation. Well, the 11th term, I take 11 and I plug it in. But make sure, because some of you use like the rate to keep going, which is fine if all it's looking for is the 11th term. You could keep adding to this term. You'd add it, so this is the 9th term, then the 10th term, then the 11th term, which would be fine if all the goal is to get that. But if the goal is to also get this equation, you have to know how to be able to do it. So I've said it several times, but I'll say it again. If it gives me an arithmetic, I immediately change it to linear. And then I solve it using slope, y2 minus y1 over x2 minus x1, and the slope point slope form of my equation, which is y minus y1 equals m times x minus x1. Yeah.
Wait, do we have to put it in the form of a?
Yeah, so if it asks for arithmetic, you want to put it back in arithmetic.
Okay.
Yeah.
How did you get the 8 and 0?
The a and 0. I took a point.
Oh, okay.
Right. I just took 1 point. I found my slope, and then I took a point and I plugged it in. It doesn't have to be a0 if you use the slope. If you're using it as linear, it doesn't have to be a0. If you wanted to plug it into the arithmetic form, you either have to adjust what you're subtracting from n, right? Or you have to plug in a0. So that's why, or a1, you plug in a1 to the arithmetic. I think it's easier to do slope.
Okay.
Yeah. Alejandro.
I have a question on another.
Okay, let me go. Any questions on 1 before I move to 2?
Is the arithmetic and the linear like final equation going to be the exact same?
Yeah, minus the variables, but yes. Okay, and the second one is, you want to go back?
Yeah.
Okay. Okay, now we're geometric, right? And so geometric, even if it had said it was exponential, I would change it to geometric so I can do the big little trick. So you're given A3 and A6. So bigger base, which is A6, is going to go on the left. A6 would equal A3 times R to the difference between those numbers, which is 3. A6 is negative 4. A3 is 32. R to the third, divide. R, that should be a third. R to the third is negative 1 over 8. And then I would cube root it. So without a calculator, this will be something that is cube rootable if it was a cube root. Okay, if it was a square root, it would be something that would be a perfect square. If it then wants you to find another term. So then my 7th term, 3 choices really. I could set up a geometric using the big as 7 and the little as 6, or the big as 7 and the little as 3, or I only have to go one more term. So I could just take my A6, which is negative 4, and multiply it times negative 1/2. So you definitely want to look for things like that. That will save you time, okay? Even if it was 2 terms, it's probably easier to just multiply it twice than it is to plug it into your equation. All right, so given the graph for f as a domain of negative 3, 5 and a range of negative 3, 7, let g of x equal negative 3f times, or f of 2 times x plus 1 minus 7. So because we're affecting domain and range, we're looking at what would change the x values and what would change the y values. Everything on the inside is changing what? The horizontal. Horizontal is x or y. X is domain or range? Domain. So all that stuff is going to change my domain. When you do domain, you have to go innermost parentheses first. It should be logical. This is like order of operations. I would work innermost parentheses first. So the plus 1 on the inside really does what? Left 1. So I'm going to take my domain. I'm going to subtract 1 from it. So minus 1 and minus 1. Now my domain is negative 4, 4. And then the 2 on the front is what? What? Horizontal? Dilation by a factor of 1/2. So I'm now taking this, I'm multiplying by 1/2. So my domain now became negative 2, positive 2. I'm done with domain. Now I go range, and range is everything on the outside of your parentheses. So the negative 3 on the front does what? Vertical dilation by a factor of 3? Vertical. Dilation. Well, the 3 is a dilation by a factor of 3. The negative, if I'm describing the transformation, is a reflection over the x-axis. Yep, flips it upside down, right? Okay. But when I'm changing it, I do them together. I do the negative 3 together. And I have to do the negative 3 and then do the minus 7. So I'm going to take the negative 3 and multiply it times my range. So negative 3 in here is 9, negative 21. And then I apply my vertical shift, which a minus 7 on the outside means? Down 7. Subtract the 7. 2. Why can't my brain work? 14. Wow. Yeah, 14. Negative. Oh, they're both negative. Sorry. Negative 28. Yep, I didn't even read my own negative. Is that in the right order? No, I got to switch it. Okay, remember inside, do inside out, and it will help you out. Inside means left, right, then multiply by what's on the front, then add or subtract what's on the outside. Work your way in and out. All right, now we got to exponential. So this one says the exponential function g is given by g of x equals 3 times, I whited out that little negative afterwards. It's weird. If it was on the front, it would be a reflection, but there it's weird. Okay. So what kind of graph, what does this look like? It's decreasing because that fraction has decay, right? So is this increasing or decreasing? Is it concave up or concave down? Ooh, up. It's on the U. And limit notation. Oh, g of x. As it goes left, it's going to infinity. You're doing good. And as it goes right, it's going where? 0. Why? Horizontal asymptote's at 0 because there's no vertical shift. Okay. I can't. All right, so the table below gives values for a function f at selected values of x. Use the table to answer. It says let g of x equal 2 f of x over 2 minus 3. Find the following value. So my goal is to find g of x, but after I change my x values. So I'm going to look at my x values, which are that top row, and I'm going to look at my transformations here. Which of these are going to affect your x values? The inside. Okay, this has an x over 2. What does that mean? This is a horizontal dilation by a factor of? Good, factor of 2. So I would be multiplying all of these by 2. But really, I just want the one that's going to result in negative 10, which is this guy. 2 times negative 5 is going to become negative 10. Now I know which one I want, but I have to alter the y here. So I go back to this. What does the 2 on the front do? Multiply it by 2, so it's a factor of 2. What's the minus 3? Move it down 3. Which one am I going to do first? Multiply. So 2 times 2 is 4. Minus 3 is 1. All right, 6 says the function f is given by f of x equals 36 to the x plus 1/2. A horizontal translation of the function y equals 36x. Express it in an equivalent form in which, notice, there's nothing added in the exponent to indicate a vertical dilation. So remember, a horizontal translation is the same as a vertical dilation. This separately would be 36 to the x times 36 to the 1/2. Because when we multiply, what do we do to our exponents? We add. So then this becomes 36 to the x times 6, because that would be the square root of 36. And which part of that is a? 6, because it's the one that's not being raised to the power. If it had asked for b, it's 36. This is the same as square root 36. Okay. All right, let's go through it. So first of all, the context at the top is really not that important. It tells you, it tells you where the data comes from, but the data is what's important, and the data is labeled on the left-hand side. If it wasn't, and you were trying to figure out like what your input and output were, maybe then it matters. But it basically just says that there's a lake frozen over, the spring brings warmer water and it melts the ice. The table below gives the area of the ice in squared feet at various times in the days since the beginning of spring. And it's actually in millions of square feet, okay? So the time is in days and the area is in millions of square feet, which is important when we go to explain it in this context. So you have to know how to do this type of question both with a calculator and without a calculator, okay? Without a calculator, you'd have to look at the data, and it might say it's exponential, but it also might say figure out if it's exponential or linear. How would you be able to do that? If it's exponential or linear. If it's exponential, you're multiplying by the same thing each time, right? If it was linear, you'd be adding the same thing each time. So then if it's exponential, what we need to know is the base. Without a calculator, that base is your ratio, right? Your common ratio. How do I find a common ratio without a calculator? Literally divide this one by that one or this one by this one. Does that make sense?
Yes.
Okay. How would you find your A0 without a calculator?
It's right there.
This is my A0. It gave it to you. If it didn't, let's say it only gave you A1, how would I find A0?
Make the formula.
I would go backwards or divide by it, or you could do the formula and A0 to A1. But you could also just divide by your R once, and it would get 2.
We do 2 divided by 2.
You would do 2 divided by 2.5. Yep. Okay. So again, you have to know how to do it. Like, the numbers are not terrible, but you have to know how to do it with and without a calculator. With a calculator, I'm going to run the regression. So I'm going to my stat. I'm typing in this data. So it's 0, 1, 2, and it's 2.5 to 1.6, and I'm going to run the regression. Okay, so I'm running the exponential regression. And I'm storing it. Okay, so here's my equation. Y equals, and this time it's A of t. A of t equals, the A0 is 2.5, which is consistent with my chart, times 0.8, which is what I would have gotten had I divided them, raised to the t. Then it says, when will the area reach 1 or 0.7, and it should have been millions of feet, but is area my input or my output? Output. So I want to know when the Y2, I'm going to make, God bless you, I'm going to make Y2 0.7, and then I'm going to graph it. Oh, my window's all messed up. Hang on. Obviously, you want to adjust your window to whatever's going to make you see what I've got, what you've got. Mine's huge right now. And my blue is the exponential, and the red is going to be the 0.7. I want to know where they cross, so I'm going to go second, trace, intersect, enter, enter, enter. And my intersection occurs at 5.7046. So 5.705
Do we have to say that, or can we just say
days.
In 5.7 days?
Sure, that's fine. Okay. If it said on what day, that's when we got around it, right? But if it's saying, you know, when does it happen? It's 5.75. That's fine.
Yes.
Good. All right. So then C says, use the given data to find the average rate from 0 to 2. There's 2 ways to do this. If I use the given data, I already have it. I'm going from 0 to 2. I could literally do 1.6 minus 2.5 over 2 minus 0. So 1.6 minus 2.5 divided by 2 is negative 0.45, which makes sense because this is getting smaller, right? Okay, the area is decreasing. You also could go alpha y equals, bring in your fraction, alpha trace y of 1.6 minus alpha trace y of 2.5 over 2. I did 1.6, 2.5, right? Is it 2.5?
It would be
Oh, I'm so dumb. Sorry, I'm not dumb. I made a mistake. Delete. Alpha trace. I'm plugging in. This would be 2 minus, this would be 0 over 2. Same answer. Okay, so you could do either way when you're using the given data. If I didn't get given that data and asked me to use the regression, then I obviously have to use the regression, but I have those 2 points.
I'm sorry, just for part I, if we didn't have a calculator, why would we need to go to 0?
Because this equation, your geometric parent function, a b to the t, is a0. Because there's nothing after the t, right? In geometric, it's A1 times n to the n minus 1. We subtract, right? If it's geometric, that base is A0. That's your initial amount.
So we would do like a of 1 times, you know, we would find r.
You would just do like 2 divided by 2.5 to find r. Or 1.6 divided by 2 if that's easier to find r. And then your A0 is the one that has the 0.
Okay.
If it wasn't there, you'd have to work backwards. Like if I gave you A1 but not A0, now you got to divide by your r. So you work backwards.
So you would divide like let's say 2.5 was had x is 1. Would we divide 2.5
By the r, which is 0.8 this time. But yeah,
to get
the one before it.
Okay.
Yep. Okay, then it says, what is it? Explain what this means in this. Well, let me answer this question, and then because it's easier to hold the calculator, and then I'll go back to the explain. So A of 4 means what happens when my input value is 4. So alpha trace 4, and I get 1.024. Okay. All right. Now let's talk about what does it mean in this context. Change or no?
Yeah.
Okay. So what do you
I
got?
would say over the first 2 days, the ice sheet decreases by 0.45 million square feet every day.
Good.
That works.